Hi, my name is Rahul Agarwal and I'll be presenting you my internship project. I'm doing my internship at M2ET, which is a subdivision of the parent company Paradigm, headquartered in US. I'm doing my internship from Bangalore as a data scientist. Before anything, let me tell you a bit about the company itself. So, M2ET is a new age digital technology solutions which focuses heavily on smart city implementations. This involves installing several IoT devices in cities where the government supports and also in countries outside India like US, Spain, etc. They also have their own dashboard called Atlantis where they monitor all these connected devices and generate reports. Now we as data scientists have been given the job of fetching these sensor data through API calls and then provide analytics. Since it's a new team and I am the first hire in the team, I have been assigned multiple projects to work upon, and the journey has been enriched with lots of learning and working on live projects. I would also like to thank our mentor, Mr. Sanjeev Jha, who has been a constant guide and support, and it's been a pleasure working with him. So, the objective of this 6 months curriculum has been to complete the 24 weeks internship uh, as required by our university, then to apply our knowledge, both theoretical and practical, which we have gained during our BTech course and solve real life projects. To gain industry experience, which might give us an edge as an employee, to work hard and try to convert the IP to job. Now, I would like to give you an overall summary of the projects that I have been enrolled since January, and then a detail of one of the major projects that I have been doing since the last 2 months. So, during the beginning of my internship, I started I was assigned to do a lot of research work pertaining to road accidents, like when and where road accident is likely to happen in a particular city, which are the probable hotspots in the city, and how people have dealt with this problem statement. Another use case was related to street lighting, like what are the existing smart solutions that have been proposed mostly to avoid unnecessary lighting at all times and to dim the lights when it's possible. This gave me an overall uh, broad approach of how to approach a problem. Then, since we needed data for analysis, my task was to find out open data sets available on the internet related to use cases like traffic and road accidents. This is when I got to know about UK data sets. Um, Also, other data sources like Here Maps, Wonderground, which provides weather information, Google, etc. Then once I got the data sets, I tried a bit of modeling on historical data sets on traffic, on UK traffic data to determine or to predict the next day congestion. This is where Here Maps came to my help which provides real-time congestion analysis. Then I was assigned a major project on waste management, which required me to explore a lot on GIS for both map visualization and traveling salesman problem. So the challenges which I faced since the last 5 months is firstly, I had no previous knowledge on GIS, which made it difficult for me to get a quick start. But thanks to my mentor who gave me sufficient time and guidance to get familiar with it. Then, secondly, data dependencies. Since this project was outsourced to us by Cisco, we had to be dependent upon their APIs to get the data. And sometimes their CDP APIs would not respond. And also, it was difficult to get the historical data. So we had to dump the real-time data to do some sort of analysis on the collected data sets. thirdly, the platform integration. So it's always a challenge to explain your work to the development team and to explain the use case which we have followed, or the approach we have followed to solve the particular problem. Uh, so platform integration has been a challenge, a major challenge. And the tools that I have used is Python for coding, Jupyter Notebook as an IDE, uh, and also a sort of platform where we demonstrate our technical work. Then Anaconda as a platform uh, for major for large scale data processing. Then scikit-learn for modeling. Then ArcGIS as ArcGIS for simulating the traveling salesman problem. Grasshopper for uh, Grasshopper provides route optimization solutions. Folium is an open source tool which provides map visualizations. Now I would like to give you a small demonstration on a couple of projects. One is related to incident management, which is also called what if analysis. And second is on waste management, where I'll demonstrate the route generation and also bin status prediction for the next day. The first project that I want to demonstrate is the crisis management. Say something happened somewhere in the city, say a road accident or a disaster, and the government is not planned enough to take care of the situation. So there'll be a chaos near the point of accident. This project aims at providing the location to the nearby hospitals and police stations, and also the traffic condition of the nearby areas, so that the victims are taken to the hospital in the quickest amount of time. So the red marker represents the point of accident. These green markers are the hospitals, and the blue markers are the police stations. So we can see the name of the police station, the distance, the estimated distance from the point of accident, and the travel time. These data have been collected from Here Maps real-time API, and if we click on the marker, we get the congestion level of the nearby roads. So this high-tech flyover has the lowest congestion, whereas some other roads have medium to high congestion levels. The second project that I have been working on since the last 2 months is related to waste management. This has been outsourced to us by Cisco, and the vendors are from the city Granada in Spain. They wanted a solution which optimizes their bin pickup schedule, which means that the truck should start at a particular time of the day, serve only those bins which are likely to get filled, and that too in the sequence which is the shortest, so as to save on fuel and labor costs. All this has been made possible by ArcGIS Traveling Salesman tool. Now, to show the flexibility of the model, we have divided our class into separate functions, which takes input in different formats. Uh, First takes the input about the vehicles and the pickup locations from sample Excel files. Second takes it from the parameter directly, and third takes directly from the vendor's API, which is the live data of bins deployed in the Granada city. Now again, to show the possibilities, we have created 5 use cases, in all adding different constraints to test the optimization capabilities. So in the first use case, uh, We have the truck information like the starting and the ending point, and also the truck capacity. So vehicle 1 start point and end point, then vehicle capacity. All other things like the earliest start time, the end time, the maximum distance it can cover, all are set to default -1. And these are the pickup locations. So if we run the model, it gives us the estimated time and distance that the individual trucks will travel. Also, the sequence in which each truck will travel so as to cover the shortest distance. So first it will start from the depot point, it will go directly to pickup 3, then pickup 2, 4, 9, 7. Then vehicle 2 will take a different path and cover a different set of bins. This has been represented or visualized on a folium map. So all the blue markers represent the pickup points. It starts from this green marker, which is the depot point, and the red is the landfill. So one path is taken by the blue marker and the other by the green waypoint. Similarly, in use case 2, we have added a constraint so as to certain pickup will be available during certain time interval. So this pickup 4 will be available only during 1 to 1:15 p.m. to 1:30 p.m. So the model will adjust itself to visit the pickup location at that particular time interval only. So again we have a visualization on the folium map. Then in use case 3, we have limited the driving capacity of individual trucks to 6 kilometer, 5 kilometer and 10 kilometer each. So here are the input vehicles, the route statistics, and the individual truck information. So here we can see there are 3 paths, one in blue color, one in green and the other in brown, and they all end up at the same landfill. Similarly, in use case 4, we have tested the functionality where we have provided more vehicles and than what is required. So the model will adjust itself to choose the optimum vehicle that is required to for all the pickups. So here we have 5 trucks, but the model will only choose 3 vehicles. Actually 4 vehicles, not the 5th one. And here is the map visualization. Then the second format in which we can provide input is through parameters. So we pass the list of pickup locations and a list of vehicle information, and then the same way we get the output of the total distance, time, and the sequence in which the pickup should be done. Then the third and the final format is the CDP, which is the Cisco's API, dashboard API, which gives us the live data coming from Granada City. Then we have bin pickup prediction. So this is another use case where the objective is to predict in advance which all bins are likely to get ready for pickup the next day. So we are predicting in advance and scheduling the pickup on the current day. So this is done on the basis of historical data, which includes looking into their individual bin fill rates, the locality where the bins have been deployed, the date time, etc. So here the target variable is whether the bin is ready or not, and we have used classification modeling to predict whether the bin is going to be ready for pickup the next day or not. So we have pre-processed the data, the historical data for Granada city. Then we have trained the data, and the model that is generated is used for getting the prediction on tested data. So the testing data is the 7 days data, the last 7 days data for each bin, and it will predict on the eighth day, like what is the status of the bin the eighth day, and we are getting a good accuracy score of 97%. Then we are also using regression to predict for the next 7 days, not just one day but 7 days pickup prediction. So the input, the target variable now changes to the fill rate, the fill level, and the prediction of the next day becomes the input to the model again, and similarly for the next 7 days it goes on. So we train the data after appending the prediction of the next day to the historical data, and then again test for the next day. Also, for once we get the prediction for the next day, we also generate the route and store it into separate CSV files, so that when we need the JSON, when the driver needs the JSON file as to which all bins he should traverse, he does not have to run the model but just take the file from the directory and do the scheduling. So there's a separate function which loads the route information of the 7 days. Finally, I would like to conclude by saying that the overall internship experience has been quite valuable towards my growth as a future administrator. And since I have been a part of a startup, I have had more responsibilities towards my project, and I have worked even after office hours to meet the deadlines. And all this is gonna make me a stronger and better employee. Thank you.